Hey everyone, I'm going to create a video for homework question number 2 because I realized it was a bit of a beast, and it'll be helpful for you to come back to this video and review it. Okay, so here we go. Reading the problem. First of all, the directions do tell us to find the distance, that's ultimately what we're looking for, between a point and a line. Alright, so just kind of recognize, we've seen a question like this yesterday in class. You went home to do it for homework, or attempted to, so here we go. I'm going to color code some things. So we have this line, which contains 2 points. So I'm going to sketch over here what the heck is going on. Just get a visual of it. So 11 is way over here and down 1. So here's 11, negative 1. And then negative 3 is a little bit here, and negative 11 would be way down here. So I'm just sketching negative 3, negative 11. Okay. And basically, here's the line connecting them. All right, so this is line L. Got it. It goes on forever and ever. Next, there's this little point called P. Point P is negative 1, up 1. Okay, so right here, here's P, just chilling, negative 1, 1. All right, that's it. What we need to find is the distance from line L to P. The way that's done is to first, well, there's a lot of steps involved, but to understand what we need to do, we need to come up with the equation right here. Whoops. We need to come up with the equation. Stop doing that. I'm going to use a dashed line for a minute here. Of this line, so for the reference in this video, I'm going to call it line P, lowercase p to stand for perpendicular. So we have capital P as point, but I'm just going to use line lowercase p because it stands for perpendicular. Right? It has to be perpendicular to the red line, line L. Okay, so we need to come up with the equation of line P. Then we're going to find, I'll color code this intersection point. And lastly, we are then going to calculate the distance of that using those endpoints. That's the idea. Okay. Here we go. To calculate line P, I need to first create the equation for line L. With that being said, we need the slope of line L. So I'll make a little note here. This is all for line L. All right, so focusing on the 2 points that were given, y2 minus y1, negative 1 minus negative 11. I'm just going to call that plus 11 because subtracting a negative. At this point in the class, we've seen enough of this. Let's just call it plus 11. And then 11 minus 3, or negative 3, becomes plus 3. Ultimately, I have 10 over 14, which simplifies to 5/7. That's the slope of line L. Next, I'm going to choose a point on line L. Let me go with this guy right here. Boom. I'm going to use this, 11, negative 1, because I want to. And we're going to say y minus y1 equals mx minus x1. And I'm going to substitute in what I just highlighted there. Check it out, okay? So my x1 I'm calling 11, my y1 I'm calling negative 1, change of signs, and then my slope from above was 5/7. Okay, I'm going to have an algebra conversation with you guys right now. I could distribute 5/7 all day and night. I'm going to just alternatively first multiply by 7 everywhere. I'm going to multiply everything by 7 because when I do that, this becomes 7y. That's easy. this becomes 7. That's easy. And when I multiply 5 sevenths by 7ths, it just becomes 5, which is easier than 5 sevenths. Now I just need to distribute 5. So I have 7y plus 7 equals 5x minus 55. And now I'm going to subtract 7. 7y equals 5x. Let's see. Taking away 5, then 2 is like 62. And then divide by 7, I get 5 sevenths x minus 62 sevenths is the equation of line L, that red line in the picture. Pretty gross. We're going to need that, though. It is what it is. Okay, now back to the plan. We need the equation for line P, the perpendicular line. All right, here we go. Part 2, find the equation of the perpendicular line. Perpendicular line. Well, if it's perpendicular to line L, it's going to have a slope of opposite reciprocal. Opposite reciprocal. And let's look at our diagram. What point do we know on that line? Not the intersection. That's actually step 3. We're going to find that later. But way over here, negative 1, 1. That green point, point P. Negative 1, 1. So we use negative 1, 1, which is on that line. And here we go. Y minus y1 equals mx minus x1. We're going to substitute in the x, the y, and the slope. Y minus 1, got you. Negative 7/5. X minus negative 1. Let's just call that plus 1 from now on. Here we go. Algebra conversation. I could distribute the negative 7/5. I don't want to. I'm going to multiply everything by 5 because it's easier. Okay, so we have negative 7. X plus 1. Distribute the negative 7. And adding 5 to both sides. And dividing by 5, both sides. Gives me this equation. This is the perpendicular lines equation. Going back to the picture. Cool. Now that I have the equation for the red line and the equation for the blue line, I can find where two lines intersect by solving a system of equations. Everything we learned in Algebra 1. Oh, you learned a lot more than that, I hope, in Algebra 1. But we can take what we have, or what we're looking at right here, the red and the blue equation. We're going to set them equal to each other and solve for x. So I just need a little space here. Let's see. The red line's equation was 5 sevenths x minus 62 sevenths. And that's going to equal negative 7/5 x minus 2/5. Let me just make sure I copied all this correctly. Yes, I did. Okay, and so that this is clear, I'm going to color code this back in the original part of the video. Original opening, right before I threw that highlighter on here. I'm going to erase the highlighter. What I'm doing right now is finding, in step 3, I'm finding this point. That's what I'm doing right now. This algebraic move is going to give me that point. All right, so now we're locking in just here. I know what I'm doing. Now I'm going to do it. First thing, if I had a calculator, even though the fractions scare the heck out of me, who cares? A calculator does work, but I don't have a calculator. I don't like fractions. I'm going to multiply everything by 7. Why? Because it's easy. This becomes 5x. This becomes minus 62. The right side becomes, let's see, if I multiply by 7, that would be, let's see, I'm multiplying by 7. Oh, that's not bad. Negative 49 fifths. And if I multiply by 7, negative 14 fifths. Cool. I don't like the fifths. Guess what I'm going to do? Multiply by 5. Multiply everything by 5, 25x. 62 times 5. Let's see, 60 times 5 is 300. 2 times 5 is 10. This is 310. Multiplying by 5, mad easy over here, minus 49. and minus 14. That was easy. Cool, look at that. I no longer have fractions. So let me add 49 to both sides. That's like adding 50 to both sides, which would be 75, but I'm one short. So this is going to be 74x. And then I'm going to add 310 to both sides. Doing this in my head, 296. Actually, alright, I'm kind of lying. No, I did it in my head, I promise you. But I'm just double checking that I have it right here, 296. And then I divide by 74. I'm not going to lie here. I did use a calculator at this point. And by the way, you can use a calculator this whole time, but And this ended up being, let me actually kind of go somewhere with this. I want to use purple-ish. The x coordinate of that intersection ends up being 4. Wonderful. Going back, what did I just find? I now know this point right here is 4. I need the y coordinate. How can I get the y coordinate? I can either substitute in 4 into the blue perpendicular line or the red perpendicular line, whatever one we want there. And we have both those equations. So if you like this, that looks pretty scary, but if you like that, you put a 4 right there and see what you get. Let's see if the other one's any easier. Son of a gun, it's not. I have to put a 4 right there. Find the y coordinate. Since they're both kind of gross, I'll just go with this one right here, just because it's in front of me. So negative 7/5 times 4 minus 2/5. So to find y equals negative 7/5 multiplied by 4 minus, what was it? I forgot. 2/5. Let's see what we get. Okay, back to my no calculator conversation. This is negative 28 over 5 minus 2 over 5. Hey, those have the same denominator, so that just means I combine the tops to negative 30 and divide by 5, which is, look at that, negative 6. So the y coordinate at that point is negative 6. And if you used the right equation, you would have found the same thing. All right, back to the diagram. This is now negative 6. We're almost done. Finally. What was the ultimate question? To take this point and find the distance to this point. This is what we crave, that segment right there. And from earlier in our course, we know the distance formula. We find the square root of the run squared plus rise squared. So at the end of the day, number 4, we're now finishing the question. Yay. Part 4, the big one. Yay. Point P was negative 1, 1. We found the intersection as 4, negative 6. And the distance between those 2 points is run squared plus rise squared. Here we go. Negative 4 minus negative 1. 4 minus negative 1, that's like 4 plus 1 squared. That's my run. Negative 6 minus 1, that's like nothing. Negative 6 minus 1 squared, and I'm going to add those together. Okay, so this is 5 squared, known as 25. Negative 7 squared, positive 49, for a final answer of the square root of 79. Oops, nope, not 79. 74, I was looking at that 9, which, using a calculator, comes out to be about 8.6. And since we weren't told inches, miles, feet, I'm just going to put units, whatever. If someone told me the units, I would fill in the units right there. But that's it. That's our final answer. It is definitely a beast. But refer back to this video. I did a lot without a calculator to try to grow your algebra strengths, your number strengths. You obviously have access to a calculator. Work carefully as you proceed through these questions.